the universe is an ever-expanding frontier of mystery and wonder. Over centuries, humans have ventured further and deeper into understanding the vastness of space, but just when we think we've reached the limits of our knowledge, new discoveries come along that shatter everything we thought we knew. This is especially true with the advent of the James Webb Space Telescope, which has recently unveiled a series of groundbreaking revelations that challenge the very foundation of our cosmological models. These findings raise the question, are our theories about the universe, including its age and structure, still valid, or have we been on the wrong track all along? The implications of these discoveries are so profound that they make even the most seasoned scientists reassess their long-held beliefs about the cosmos. This is not just a revolution in space exploration, it's a revolution in how we view our place in the universe. For most of human history, our understanding of the cosmos was limited to the knowledge available at the time. Centuries ago, people believed that the Earth was the center of the universe, with everything else revolving around it. This geocentric model dominated Western thought for millennia, until it was finally upended by Copernicus, Galileo, and Kepler, who showed that the Earth, in fact, orbits the Sun. However, even this heliocentric model didn't explain everything. The notion that our solar system was just one of countless others in a vast universe took time to gain acceptance, and it wasn't until the 20th century that we began to understand the true scale of the universe. Edwin Hubble's discovery that galaxies are receding from us, implying that the universe is expanding, was one of the most important milestones in modern cosmology. His observations laid the groundwork for what became known as the Big Bang Theory, the idea that the universe began from a singular, incredibly hot and dense point around 13.8 billion years ago. At its core, the Big Bang Theory suggested that the universe had a beginning, a moment in time when space itself began expanding. From that point of origin, matter, energy, and the very fabric of spacetime began to stretch outward. This theory was revolutionary, offering an explanation for the origins of galaxies, stars, and even the elements themselves. Yet, as we dug deeper into the theory, we began to realize that there were still many unanswered questions. What exactly happened in the first moments of the universe's existence? How did galaxies and stars form? And what are the true properties of dark matter and dark energy, which make up the majority of the universe's content but remain largely invisible to us? These are just a few of the pressing questions that have driven cosmologists to continue exploring and refining our understanding of the universe. For many years, these questions remained at the forefront of scientific inquiry, and while significant progress was made, there were still many gaps in our knowledge. But with the launch of the James Webb Space Telescope in late 2021, everything changed. Webb is not just another telescope, it's a revolution in the way we observe the cosmos. Equipped with an array of advanced instruments, including a powerful infrared camera, Webb can peer deeper into space than any telescope before it, allowing us to observe galaxies and stars that formed in the very early stages of the universe's existence. What Webb has revealed has been nothing short of astonishing, and it has forced scientists to rethink some of their most fundamental assumptions about the cosmos. One of the most significant revelations from Webb came in 2023, when scientists discovered galaxies that should not even exist according to our current models of the universe. In particular, the telescope observed a series of massive galaxies that appeared to have formed just a few 100 million years after the Big Bang, at a time when the universe was expected to be too young and too chaotic for such large structures to have formed. These findings, made by a team of astronomers led by Evo La at Swinburne University of Technology in Melbourne, Australia, were truly shocking. When La and his colleagues first ran the data, they found that the galaxies in question had a mass of 100 billion stars, and that they were located about 13.1 billion light-years away, placing their formation at a time just 500 to 700 million years after the Big Bang. This was completely contrary to our understanding of galaxy formation. According to the current cosmological models, the first galaxies were expected to be much smaller and less massive, with the first full-fledged galaxies not appearing until much later in the universe's history. The discovery of these enormous galaxies so early in the universe's existence is a major puzzle for scientists. LA's reaction to the discovery was one of both excitement and disbelief. He had expected to find early galaxies, but not ones of such incredible size and mass. The implications of this discovery are profound. Either the matter density in the early universe was far higher than we previously thought, or galaxies were forming in ways that are completely unknown to us. Either scenario forces us to reconsider how galaxies and stars form, and may require a major revision of our models of cosmology. The size and mass of these galaxies challenge the accepted idea that galaxies evolve from smaller clouds of gas and dust, gradually growing larger over time. If these galaxies were able to form so quickly and so large, then it suggests that galaxy formation might be a much more complex process than we had previously imagined. The discovery of these so-called unthinkable galaxies is only the beginning of what promises to be a series of breakthroughs that will continue to push the boundaries of our understanding. Webb's capabilities allow us to look further into the past than ever before, and with each new observation, it seems that the universe is revealing itself to be far stranger and more complex than we could have ever anticipated. In addition to the discovery of these early massive galaxies, Webb has also uncovered a galaxy, Jade's GSZ 140, which holds the title of the oldest known galaxy ever observed. This galaxy formed a mere 290 million years after the Big Bang, and it is far larger and more developed than previous models suggested possible for such an early time in the universe's history. Not only did it form relatively quickly, but it also appears to contain elements like oxygen and hydrogen emission lines, indicating that large stars had already completed their life cycles and exploded as supernovae. This discovery adds yet another layer of mystery to our understanding of galaxy formation. How could such an ancient, large, and developed galaxy have formed so early? The implications are mind-boggling, as they suggest that the processes by which galaxies evolve might be far more rapid and dynamic than we had previously believed. Once again, cosmologists are left with more questions than answers, as the observed galaxy seems to defy the conventional models of star and galaxy formation. The discovery of these early, massive galaxies is forcing scientists to rethink everything from the initial conditions of the universe to the fundamental processes that govern the formation of cosmic structures. While these revelations are undoubtedly thrilling, they also underscore the limitations of our current understanding of the universe. The questions raised by these discoveries are profound, and they may require entirely new theories to explain them. The early universe, it seems, was a far more dynamic and complex place than we have ever imagined. These discoveries, made possible by the James Webb Space Telescope, are not just rewriting the history of the universe, they are also challenging the very framework of modern cosmology. At the heart of the mystery is the issue of cosmic reionization. This is the period in the universe's history when the first stars and galaxies formed and began emitting light, ionizing the hydrogen gas that filled the universe and making the cosmos transparent to radiation. The precise timeline and mechanism of reionization has been a topic of debate among scientists for decades. Previous models suggested that the first galaxies and stars would have been relatively small and dim, and it was thought that reionization would have occurred over a period of several 100 million years. But Webb's discoveries are forcing scientists to reconsider this timeline. If large, luminous galaxies were forming just a few 100 million years after the Big Bang, then it suggests that reionization might have occurred much earlier than previously thought, possibly even within the first few 100 million years. This raises new questions about the role of the first galaxies in ionizing the hydrogen gas and how they may have influenced the overall evolution of the universe. In addition to these discoveries, Webb has also provided new insights into the nature of dark matter and dark energy, two of the most mysterious and elusive components of the universe. While we cannot directly observe dark matter and dark energy, their effects can be seen in the behavior of galaxies and the expansion of the universe. Webb's observations are providing crucial data that could help us better understand these enigmatic forces. For example, by studying the way that light from distant galaxies is bent by gravitational lensing, scientists are gaining a better understanding of the distribution of dark matter in the universe. Similarly, by observing the behavior of galaxies at different points in the universe's history, Webb is shedding light on the role of dark energy in the accelerated expansion of the cosmos. Each of these discoveries is part of a larger picture, one that is rapidly evolving as new data from Webb continues to pour in. the mysteries of the universe are far from solved, and in fact, we are just beginning to scratch the surface. The implications of these findings are far-reaching and could lead to a complete overhaul of our understanding of the universe. Webb's revelations are a testament to the power of scientific exploration and the constant pursuit of knowledge. What we once thought we knew is being upended, and with each new discovery, we are inching closer to understanding the true nature of the cosmos. In the end, the most exciting part of these discoveries is not just the answers they provide, but the new questions they raise. The universe is an infinite puzzle, and with the help of tools like the James Webb Space Telescope, we are piecing together its secrets. As we venture further into the unknown, there's no telling where these revelations will lead us. But one thing is certain, the universe is far stranger, more beautiful, and more complex than we could have ever imagined. And with each new discovery, we are that much closer to understanding our place in the vast, cosmic expanse.